Hi, Assalamualaikum Doctor. My name is Nurusada Darius. So I will explain about the project 1. The air quality in Malaysia is reported as the API, Air Quality Index. The Air Quality Index was introduced as an index system for classifying and reporting ambient air quality in Malaysia. The API value have been divided into 5 ranges, which is good, moderate, unhealthy, very unhealthy, and hazardous, based on possible health effects. The API for a given time period is calculated based on the site index value for all the 5 air pollutants included in Malaysia API system, which is sulfur dioxide, nitrogen dioxide, ozone, carbon monoxide, and particulate matter below 10 micron in size. We used 2019 Pollution Air Quality Index data. From the evaluation and survey that was conducted, we discovered that throughout 2019, the month of March had the greatest level of air pollution index, which was at a moderate level, and the month of April had the second highest level. Air pollution index can rise when air emissions rise. For instance, during peak traffic hours or when a forest fire breaks out due to the wind or a lack of dispersion of air pollutants. Additionally, the month of February has the lowest air pollution index level, where it is at a good level, while January has the second lowest level. Based on all of our observation for the year 2019, we discovered that Port-Eastern Air Quality Index is extremely good because it doesn't reach very unhealthy or hazardous level.
Assalamualaikum, my name is Najwa and I will present for project 2. The table below is our data for wind rows for 2 weeks, and at the side of the slide is the wind rows diagram. It is the wind rows diagram for Melaka, Malaysia based on 2 weeks of hourly wind data. The wind roses shown in here have additional information. Each spot is divided into discrete frequency categories that show the percentage of time that winds blow from a particular direction and at certain speed range. All wind roses shown here use at cardinal direction of north, east, southeast, southern, southwest, west, and northwest. From the wind rose diagram, we can see that the wind in Malacca during the period blew mostly from the north. In fact, the three spokes around the north direction, northwest, north, and northeast comprise 74.54% of all hourly wind direction. We calculated that by adding the frequencies of each of these direction, 27.27 plus 29.09 plus 18.18 equal to 74.54%. This also shows the wind rarely blows from the southern. The wind roses also provide details on wind speed from various directions. Examining wind from the north, the longest spoke, one can determine that approximately 8.91% of the time the wind blows from the north at speed between 2 and 3 meters per second, at speed between 4 and 5 meters per second about 7.27% of the time, at speed between 9 and 7 meters per second about 5.45% of the time, between 8 and 9 meters per second about 3.64% of the time, and less than 1.82% of the time at speed between 10 and 11 meters per second.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nafatiha Atika binti Mufazzil. So we continue to our project 2. Okay. Please note the legend at the side of the wine rose that gives the speed categories and their associate colors. The legend on the side provides additional information such as the unit meter per second, the average wine speed for the overall hours, in this case 5.47 meter per second, and the years and months of data on which each rose was booked. Simply multiply the respective frequency by the appropriate amount of time to calculate the typical amount of time that the wind blows from a specific direction and at certain speed. In our case in Malacca in January, there are 40 days times 24 hours per day in January are 336 hours. We calculate that wind blows from the north at speed of 4 to 5 meter per second is 7.27% of the time based on the wind rules. This represents 0.0727 times 336 is equal to 24.43, or about 24 hours. Typically, the winds from the north at this speed at Malacca in January.
Assalamualaikum, I am Nur Izzati Hazika. My friend and I will explain for project 3. On the left side shows the dispersion for fixed parameters. The data of fixed parameter are listed below, where the wind speed 1.5 meter per second, wind direction 149 degree, temperature 20 degrees Celsius, mixing height 1000 meter, and class A, which is an extremely unstable condition. Furthermore, as we can see, there are 3 zones, which are red zone, green zone, and blue zone, and each zone shows the different concentration. On the right side shows dispersion when wind speed change from 1.5 meter per second to 3 meter per second. Higher wind speeds often lead to greater dispersion of air pollutants, resulting in lower air pollution concentration in windy places. The air becomes more turbulent as the earth heats up during the day, allowing air contaminants to scatter in the air. On left side figure shows dispersion when wind direction change from 149 degree to 270 degree. If the air is quiet and contaminants are unable to disperse, the concentration of these pollutants will rise. Pollutants, on the other hand, scatter fast when strong, turbulent winds blow, resulting in reduced pollutant concentrations.
Hi, Assalamualaikum. My name is Fatina Izzati Hussein. So next I will continue with the temperature. So based on the data of temperature was adjusted from 20 degrees Celsius to 15 degrees Celsius, while the other factors remain constant. And the concentration data of each zone has also been recorded. However, when the temperature is raised to 15 degrees Celsius, there is no difference in concentration or dispersion when compared to the concentration at fixed parameter. Okay, next parameter is mixing height. So the data was adjusted from 1000 meter to 500 meter, and compared to the fixed value, the concentration at each zone rises. The height raised at which a pollutant such as smoke may be distributed is referred to as the mixing height. During surface temperature inversion, the mixing height drops to zero, resulting in negligible smoke dispersion. Last parameter is Pascal Gifford stability. So the data was changed from class A to class B. Class A denotes a severely unstable state, whereas class D denotes a neutral condition. However, when the concentration data was compared to the fixed parameter, the value is increased. So that's all from our group. Thank you.